We'll now continue our discussion of section 3.2, focusing on finding the vertex of quadratic functions. Let's begin with the formula. The vertex of a quadratic function. Given a quadratic function, f of x is equal to ax squared plus bx plus c. Now note this is in standard form, not vertex form. The graph of f is a parabola with a vertex given by, and we have this formula. Negative b over 2a is going to produce the x value in your vertex, and f of negative b over 2a is going to produce the y value. When we are working problems, this is the version of the formula that we're going to focus on. So let's try this. Find the vertex of the following quadratic functions using the vertex formula. Part A is f of x is equal to x squared minus 4x plus 8. The first thing that I want to do is identify the a, the b, and the c value. So for part A, the a value, remember, is the number that sits in front of the x squared. So that will be 1. The b value is the number that sits in front of the x. So that will be negative 4. And the c value is the number that sits alone, which will be 8. Now, my vertex formula says that x is equal to negative b over 2a. So let's plug into that. So I am going to, in place of the b, now notice that the negative goes in there anyway, and then I'm going to add in the b value. So I've got a negative, and then the b is negative 4. And then 2 times a on the bottom will be 2 times 1. So these two negatives make a positive. So on the top I have positive 4. On the bottom, 2 times 1 is 2. 4 divided by 2 is 2. So my x value in the vertex is going to be 2. Now, what about the y value? Our formula says to simply plug in what we got here back into the function in order to determine the y. So we will do f of 2. And we'll rewrite our function putting a 2 everywhere there's an x. So we have 2 squared minus 4 times 2 plus 8. 2 squared is 4. 4 times 2 is 8. And we have a positive 8. The 8's cancel, leaving me a 4. So the vertex is the point 2, 4. Let's look at part B. For part B, our function says g of x is equal to 3x squared plus 5x minus 1. The a value is 3, the b value is 5, and the c value is negative 1. Plugging into our vertex formula, x is equal to negative b over 2a. We're going to have a negative, and then we're going to substitute in for b. B is 5. On the bottom, we're going to have 2 times a. A is 3. And so our x value will be negative 5 over 6. We then want to substitute in for the y. So we're going to evaluate our function at negative 5 over 6. We're going to put a negative 5 over 6 in everywhere there's an x. So we're going to have 3 times negative 5 over 6 squared plus 5 times negative 5 over 6 minus 1. Now, we'll do a little simplifying here by hand, but at some point you may want to go to your calculator with it and actually calculate this on your calculator because the calculation is somewhat messy. We know that the first thing that we need to do is to do the squared. So the negative 5 6 squared will be 25, squaring the top, over 36, squaring the bottom. The next thing I'm going to do is the multiplication with the 5 and the negative 5 6. So 5 times negative 5 is negative 25. And that's going to go over 6 minus 1. So now we can say 3 times 25 over 36. And then I'm going to make some room over here. So 3 times 25 is 75 over 36 plus negative 25 over 6 minus 1. And so we know we're going to need a common denominator. The common denominator will need to be 36. So the first fraction is good. The second fraction, we need to multiply top and bottom by 6. So I have 75 over 36 plus a negative 150 over 36 minus, and this 1 could be written as 36 over 36. So now that we have a common denominator, we can add the 75, the negative 150, and the negative 36, which is going to give me a negative 111 over 36, which will reduce to negative 37 over 12. As I said, you may find that you want to use your calculator at some point to calculate that. So for our vertex, our x value, remember, was negative 5 6. And now we found our y value to be negative 37 over 12. So we're going to look at one more example here. This is an application problem. A farmer plans to use 100 feet of spare fencing material to form a rectangular garden plot against the side of a barn, using the barn as one side of the plot. Okay, so let's go ahead and as we're reading this, sort of draw a picture. We've got this rectangular garden plot. And he's going to fence it, but he only has to fence 3 sides. Because this side is the barn. How should he split up the fencing among the other 3 sides in order to maximize the area of the garden plot? So let's let x represent the length of one side of the plot. So let's let x be this side. So what else do we know if that's the case? If it's a rectangle, we know that the bottom side will also be x. And what about this side? Well, we know that the total amount of fence that he has is 100. So if we take the total, which is 100, and we subtract off what we use up here, and we subtract off what we need to use on the bottom, then we should be left with what we have to use on the side. So we're going to let that side be 100 minus 2x. So he wants to maximize the area. So let's write an equation for the area of this rectangle. Remember, area is length times width. So we're going to have the length of x times the width of 100 minus 2x. And note that when we multiply this out for area, we're going to get a formula that looks like 100x distributing minus 2x squared. And so think about what the graph of this is going to look like. It's a squared term, so it will definitely be a parabola. The number in front of the squared term is negative, which means that it's going to open down. So if this is a graph of our formula for area, where is the maximum area? The maximum area is shown on the graph at the top, at the vertex. And so in order to maximize the area, we need to find the vertex for this quadratic equation. So let's work on that. So we know that our formula for vertex says x is equal to negative b over 2a. So negative b will be, the b value sits in front of the x, so negative 100. And then 2 times a. Remember, the a value sits in front of the x squared, so the a value is negative 2. So I have negative 100 over negative 4, which gives me 25. And so what that tells me is that in order to maximize the area, he needs the length to be 25. And he needs the width to be, remember we're going to do 100 minus 2 times 25. So that will be 100 minus 50, which would be 50. And so how should he split up the fencing among the other 3 sides? In order to maximize the area, he should do a length of 25 and a width of 50. Now, notice that I did not even need to find the y value of the vertex, because as soon as I had the x, I had the length, and I could answer the question from there. If the question had asked me what was the maximum area, then I would need to actually calculate that area, and in doing so would have found the y value for the vertex.